So in this video, I'm going to review the paper 2 from your last assessment in September. It's the first time you see an original past exam paper. Slowly you need to start getting familiar with the structure and the instructions as well. As I asked you to do in the beginning when you got the paper was to read the instructions very carefully. Okay, now over time this will become faster because as you see more and more papers, you will realize that the instructions are the same. So even during the exams, you're gonna have very few seconds to go through those instructions because there won't be any different, right? One of the most important things is that for physics, you need to pay attention to the value of G. So this 9.8 essentially tells us that the G in our calculations is going to be 9.8. Now it's not clear if when you use a value of 10, the examiner is going to consider it as a mistake or not. But if you want to be safe, take the value of G that is given in the paper, and usually it is 9.8. One thing to keep in mind for the paper 2, which I will repeat several times during this video, but also during our lesson time, is that since you're going for time efficiency, you remember you're going to have for a full paper 2, you're going to have 45 minutes, okay, for 40 questions. So if we say we need some time to go through the paper at the end, you can't count for more than 1 minute per question. I would say some of them will take you less and other will take you more. Okay, so you need to be within this time range. So for some of those calculations, as I will show very briefly, taking G as 10 just for a quick estimate is going to be more than enough for you to choose the right answer from the multiple choice paper. However, for a paper 4, okay, where you need to show your calculations, it's much wiser to use 9.8 as a value. For a quick estimate, maybe just taking it, assuming it as a 10, will buy you some time. And remember, in a paper 2, you're not expected to show any work. You just need to choose the right answer. Actually, you will be given a different sheet of paper where you simply choose A, B, C, or D. It's not going to be on the original paper. Okay, that's something that we will work on later from January onwards. So enough with the instructions for the first time of this paper. Let's start having a look at the questions. First one, a light ball is held at rest at the top of a cliff. Okay, so you will see how I have highlighted some keywords in the questions. That's a strategy that I encourage all of you to do. It is released and falls through the air, eventually reaching its terminal velocity. So we should all understand from theory what terminal velocity means. It's no longer accelerating. Okay, that's very important, and that's something no longer accelerating, which means the resultant force on the object is 0. Okay, very important. If you don't know the definition of terminal velocity, you can't pick that correct answer. Which row describes the behavior of the ball as it descends? Now, the structure of this multiple choice question is pretty standard for paper 2. So you're going to have 4 options, A, B, C, and D, and then you need to find the right condition for the first criterion and the second criterion. Okay, so you need to read them very carefully. Now, the first column is asking for the initial acceleration of the ball. The ball is falling from the top of a cliff. So we should know that it falls with gravity's acceleration. So the only accepted answers could be C and D. Now the difference between them is the second option, which is the final acceleration of the ball. Now C gives you a final acceleration, final meaning the final corresponds to the eventually what happens, right? Which means it reaches terminal velocity. So eventually, with having reached terminal velocity and knowing what terminal velocity means from theory, we know that the acceleration should be 0 Therefore, we choose C and not D. Okay, that's the full analysis on question 2. Question 3. The graph represents the motion of a car. First thing I do is I'm looking at what variables I have on the x on the y-axis. On the y-axis I have speed, and on the x-axis I have time. Just by looking at this graph, before I even read the rest of the question, I should remember that the slope of this graph, okay, the gradient on a speed time graph, gives me what? It gives me correct acceleration. Okay, so the slope is the change in velocity over change in time, and the slope is going to give me acceleration. So one question here could have been about the acceleration of an object, which you could have calculated as rise over run, as you say in math, or simply 10/5, okay, for acceleration. However, the question is how far has the car moved between 0 and 5, which means we want the distance. On a speed time graph, the area, not the slope, the area now gives us the distance. And again, that's something that we need to know from theory before we walk into the exams, okay? So the area under this curve is going, under this line in this case, is going to give you the distance. It's a triangle, so we know it's base times height divided by 2. So 5 times 10, 50, divided by 2, it's going to be 25 meters, okay? So you could have done this question in less than 40 seconds if you knew what the speed time graph actually means and which variable we're looking if we want to calculate the distance, okay? Which statement about mass or weight is not correct? Which one is not correct? Masses can be compared using a balance. Of course, we can compare them using a balance. Weights can be compared using a balance. Also correct. Weight is a force. Correct. Mass is a force. That should take you, what, 10 seconds to pick the right answer? Okay, so you see how some questions you can answer very, very fast and save some time for the ones that need maybe more analysis, like the one coming up next. So mass is a force. That's definitely not the case. Mass is a scalar quantity that stays constant everywhere in the universe. Weight is a force which depends on the location on our planet or even in the universe. Now, question 5 would require some more analysis or thinking, okay? So it would require more of your time. A sphere P made of steel has a weight of 10 newtons on Earth. Another sphere Q, also made of steel, okay, so same material, has a weight of 10 newtons on Mars. The gravitational field strength on Earth is greater than the gravitational field strength on Mars. So now I'm starting getting information about the problem, okay? The fact that they are both made of the same object, of the same material, might give you some idea about the density in case you need it, okay? Gravitational field strength just talks about gravity's acceleration, g. So which statement is correct? You need to compare the mass of the sphere P to the mass of the sphere Q, okay? Or their weights. Now, we start with the standard one. So the WP, let me write it down, WP is going to be equal to MP times GE, the G on Earth, okay? And the WQ is going to be MQ times GM on Mars. And we know that both of them have the same weight. Both of them have the weight of 10 newtons, which means you can equate these two and say that MQ times GM is going to be equal to MP times GE. Okay, so far so good. Now, you also know that gravity's acceleration on Earth, so this one, GE, okay, is larger than GM. So if GE is larger than GM and you want to have this condition, you want to have this equation as valid, the only option that could make that mathematically possible is if the mass of the sphere P is less than the mass of the sphere Q. That's not an easy question, okay? You can't do that in your head. You need to write something down, okay? And that's how I would have approached it, okay? So carefully read the information from the question and then see how you can take it from there. Now, a general tip is if you see that one of the questions require more of your time, okay, like more than a couple of seconds, and still you don't have an idea how to solve it, don't stay there, especially in a paper 2. It should be the same approach on a paper 4, but definitely in a paper 2 where time really matters, okay? So if you saw this question and you're like, oh, that's a hard one, I don't think I have an idea of how to get started, just move on, okay? And make a note to come back later at the end and see what you can do. But definitely, even at the very end, if you cannot find something with your physics knowledge, just pick an answer, because remember, it's multiple choice question, so there is no excuse in leaving any of the questions unanswered, okay? Now, number 2, and that's another one that could have saved you some time. It's a very simple one that should take you less than 10 seconds. Which two quantities must be known to determine the density of a material? So you should know that density is mass over volume. So mass and volume, this should take you literally 5 seconds to solve, okay? And now you're buying more time for the question like question 5. 7. A truck is towing a car along the straight horizontal road at a constant speed. Constant speed, we should know, means that the resultant force on it is 0, okay? Maybe I need it, maybe I don't need it, I don't know. Just as an input, so you see that more information is hidden when you can read between the lines of the question. And then they also have a very nice diagram here to visualize the problem. The rope breaks. Which row gives the direction of the initial acceleration of the truck after the rope breaks and the reason for the acceleration? Again, same idea. A, B, C, D, 4 options with 2 different conditions. Direction of acceleration of the truck, which one, and then the reason. Okay, so acceleration of the truck. Once the rope breaks, we know that the truck is going to move to the right, so we can easily take out A and B. Now, from C and D, what's the difference between them? Okay, it says that the driving force is smaller than the resistive force on the truck, or the driving force is greater than the resistive force on the truck. If the truck is moving forward, then we should know that in that case the driving force coming from the engine is going to be larger than the resistive force, like air resistance or friction. Okay, so that's another question that we can solve within a minute, I would say. So C is the correct answer. A uniform beam, I highlighted uniform because it comes in many questions. Uniform beam means that the mass of it is equally distributed along its area. Okay, so the key here is for paper 4 questions that if you had to draw the center of gravity or center of mass of a uniform beam, that's always in the middle. Okay, that's always halfway through the beam for a uniform beam, which is the case for most of IGCSE. For, I would say, all of IGCSE questions, we're always using a uniform beam. Is pivoted at the center, and 2 identical masses, X and Y, identical, you see another keyword, are placed so that the beam is balanced. Excellent, which means they are at the same distances, so the beam is balanced. How can the masses be positioned? A smaller mass is then added at the position shown. Okay, so that's a smaller mass, so you add it over there. You don't know where exactly. How can the masses be positioned so the beam balances again? So of course, if they're balanced and then you add another one, you're going to create a moment. In this case, you're going to create an anti-clockwise moment. Okay, how can the masses be positioned so the beam balances? So that the beam balances again? You need to reduce the counterclockwise moment, because that's going to be the effect of the new mass, or increase the clockwise moment. Okay, so from the options that we have, if we move X towards the pivot, okay, that would reduce the counterclockwise moment, and that's the option that we take. If you move x away, then you increase the counterclockwise moment. If you move y towards the pivot, you reduce the clockwise moment, which doesn't help. And if you move the small mass away from the pivot, you basically have the same effect as moving x away from the pivot, okay? Question 9, a resultant force, I haven't highlighted anything here. Resultant force of 2 newtons acts on an object of a mass 3 kilograms for 6 seconds. What's the change in velocity? Every time you hear about resultant force and time, okay, you need this formula, okay? The Newton's second law in the general formulation. Sigma F, the resultant force, is equal to the change in momentum over change in time. Very important for both papers, okay? So most of us had forgotten about this formula, okay? So let's not make the mistake from now on. So sigma F is equal to change in momentum over change in time. You solve this one for change in time, which is going to be resultant force times delta t. The resultant force is 2 times 6, that's 12 kilograms meters per second. That's the change in momentum. Now the change in momentum, you see, so this one requires more calculations. Change in momentum, you know, it's going to be m times delta v, change in velocity. And you want the change in velocity, right? That's what you're looking for. So change in velocity, if we solve this one correctly, it's going to be delta p over m. The delta p, change in momentum, was just 12. Divided by 3, the mass is given from there, so it's 4 meters per second. Now, this is an example of a multiple choice question that requires a good amount of calculation. So this could have been also a paper 4 question for, I don't know, maybe 1 or 2 marks maximum. The next one, also with a few simple calculations. A wind turbine is 30% efficient and has an output of 2.5 megawatts of electrical power. What is the power input to the turbine? When I read it this way, I can write the equation in a very, very simple way. So the output, the 2.5 megawatts, okay, first off, I ask myself, do I need to make any unit conversions? And the answer is no. Why is that? Because my input, the information that I have from the exercise, to be precise, is in megawatts, and then all of my answers are also given in megawatts, which means I can skip the conversion from megawatts to watts. In this case, it's not needed. So the output, when you have 30% efficiency, okay, it simply means that your output is going to be 30%, okay, that's your efficiency, times X, your input, which we don't know. So I'm telling you that you are investing, okay, X amount of hours into something, or money into something, and you have 30% efficiency. And I'm telling you that your output is going to be another amount, okay? So the output is always equal to the efficiency times your input. So if you are able to write down this equation over here, you should be fine. So 2.5 is equal to 30%, which is 30 over 100, or 0.3, times X. And X is the value that you're looking for. So you solve this one very carefully and you realize that X is equal to 8.3 megawatts, so the answer is B. Another one that would require more of your time. 12. Which two physical quantities must be used to calculate the power developed by a student running up a flight of steps? This one should take you less than 10 seconds. Power, let me recall the formula. It's work over time, or energy over time. Which answer offers me those two variables? It's D, work done, and time taken. That's it, okay? 10 seconds. provided that we know the formula. That's why you will hear me over and over again saying we need to know the formulas, all of the formulas, before any physics assessment. The next one was a bit challenging, okay? The next one is another example that needs a bit more calculations. Density of seawater is 1030 kilograms per cubic meter. Gravitational field strength is 9.8. Atmospheric pressure is 101,000 pascals. At which depth in the seawater is the total pressure due to the atmosphere and the water equal to this value? Okay, everything starts with the formula for hydrostatic pressure, which many of us had forgotten. It was also needed in paper 4, which you will hear me again refer to in the other video. So delta P, change in pressure, is equal to rho, density of the liquid, in this case water, seawater, times gravity's acceleration, times the change in height or depth. You want the change in depth, right? So delta H is going to be if you solve that properly, change in pressure or divided by density times gravity's acceleration. So what's the change in pressure? It's between 513,000 minus 101,000 pascals divided by rho times g. You plug that into your calculator and you should get 40.8 meters, okay? Again, this should have taken you a bit longer to solve. The next one, it on the contrary should take you literally 15 seconds to solve. The diagram shows a wave. What are the amplitude and the wavelength of this wave? Again, same structure, four possible answers and different criteria. So amplitude and wavelength. So you look at this graph and you need immediately to identify that the 3 centimeters are basically my amplitude, okay? So the maximum displacement from the equilibrium point, the balance point. So I can cross out already C and D. And then of course they're going to give you the tricky part that they want you to fall into that trap and say, okay, is it A, which means wavelength is 4, or is it B, wavelength 8? The wavelength is the distance between two consecutive crests or troughs, so the wavelength is 8, therefore the correct answer is B. The next one, many of us struggled with. Optical fibers are used to transmit digital signals using infrared radiation, blah, blah, blah. The average refractive index of the fibers is 1.5, totally irrelevant. Which row describes the digital signal and gives the speed of the infrared radiation in the fibers? Okay, now, it is a digital signal, which means we can have continuous range of values. And again, this comes from the theory, the differences between digital and analog signal. So C and D are impossible. So A and B, signal that consists of only two values, so 0 and 1. So A and B are the only options. What's the difference between A and B? One gives you a speed of 2 times 10 to the power of 8 meters per second, and the other one gives you 4.5 times 10 to the power of 8, which is larger than the speed of light, which is 3 times 10 to the power of 8. So I know it can't be this one, okay? So the answer has to be A. Very few of us got this one right, and that was a bit disappointing. So remember, digital signal, only two values, 0 and 1. Analog signal, continuous range of values. And nothing can go faster than the speed of light, okay? Another one that should take us 5 seconds. Which statement describes a monochromatic light? Monochromatic, remember, mono, one in Greek, chromatic is the word for color. So it's one color or one frequency or one wavelength. So from all of these options, I can only choose A, light of a single frequency. A beam of light consists of yellow and blue light. The beam of light is incident on the glass prism, which diagram describes it correctly, like the refraction. A and B are off because it shows that you go from a less dense to a denser material, medium, and then it shows the wrong angle for those beams, so they should move in the opposite direction. So C and D are the only options, and the difference between C and D is just the order of blue and yellow. So yellow is on top and blue is in the bottom, and that's something that, again, we need to know from theory, the colors of the spectrum. Okay, so D was the answer. 21, another one that requires a few calculations. Radio station broadcasts a signal with a frequency at 89 megahertz. What's the wavelength of the signal? Okay, I have options in micrometers, which is 10 to the minus 6 meters. I have options in meters, kilometers, and megameters. We don't see that very often, right? For lengths. So we start with the wave speed formula, another very, very important formula for your exams. V speed is equal to the wavelength times frequency. You solve that for wavelength, frequency over speed. The speed, even though it's not mentioned here, it's the number that you can assume is the speed of light in a vacuum or in the air, 3 times 10 to the power of 8. You do that calculation, and then your number is going to be in meters, and the right answer is B. 22. A boy shouts and hears the echo from a tall building 2.2 seconds later. The speed of sound in the air is 330 meters per second. How far away from the building is the boy? So the boy might be standing here, okay? The echo would travel this distance and then come back, and we don't know this distance over here, okay? But we know that all of this journey, okay, going this way, took 2.2 seconds. So we know that the speed is distance over time. If you solve for distance, okay, the distance that the whole signal traveled is 330 times 2.2, that's 726 meters, but that's the both ways, okay, hitting the wall and coming back. What you want is the distance between the boy and the wall, which is half of that, okay, so 360 meters. Or simply you could have half the time and say my time is going to be 1.1 seconds, okay? Both would work. The next one, I think no one from all three groups got correct, if I'm not mistaken, okay? Again, same structure, different rows, 4 possible answers, and we need to find the condition that agrees with both of them. Fission and fusion, 2 types of nuclear processes. How does the total mass of the nuclides produced compare with the total mass of the original nuclide or nuclides in these nuclear processes? So we want to compare the mass before the fission and fusion to the mass of the products after that process is complete. Remember, everything depends on the equation E equals mc squared, which means you can convert the smallest amount of mass into a huge amount of energy due to the multiplication of the tiny mass with c squared, which is a huge number. Now, what we discussed in class, the difference between fission and fusion, okay, the reactants, okay, and the products, is that after the reaction, okay, the mass of those new products is going to be slightly less than even 0.1% less than the original nuclides that combined for fusion or fission. And this difference in mass is going to be converted through this equation to the huge amount of energy. So the correct answer is less for fusion and less for fission. So D is the correct answer. Table shows the composition of 3 different nuclei. So we have X, Y, Z, number of protons, number of neutrons, which nuclei are isotopes of the same element. So isotopes, same number of protons, different number of neutrons. That's what makes a difference between 2 isotopes of the same element. So X and Y, as we can see, they have same number of protons, but different number of neutrons. The Z, which has different number of protons, is a different element, okay? So that also is something we can identify very, very fast. Which change occurs in the nucleus of a radioactive atom during beta emission? Again, theory, a neutron transforming into a proton and an electron, okay? We can't help it, but we need to know the theory as well. What is a beta emission? That's the question. 36, radioactive isotope has a half-life of 8 days, which means every 8 days its concentration is reduced in half of it. Detector close to a sample of this isotope gives a count rate of 200 counts per minute. Without the source, the background count is 20 per minute. What is the count rate due to the source only after 8 days? We need to, the first thing we do, remove the background radiation, okay, the background count. So we start at T0, we count 200 counts per minute, minus the background, that's 180. So we have really 180 counts per minute due to the source. After 8 days, that 180 is gonna be reduced in half of it, okay? That's the definition of the half-life. So 180 divided by 2 is gonna give us 90 counts per minute. Which statement about the solar system is correct? How can we miss that, okay? How can we miss that question? Which is correct? All planets are rocky. Of course, that's incorrect. We have the gaseous giants like Jupiter, for instance. Only the Earth has a moon. No, we have planets with several moons, like Jupiter has many. Mars has 2 moons, okay? There are many stars in the solar system. Some of us chose that answer. And I'm like, guys, read the question, please, carefully. There is only 1 star in our solar system. When it says in the solar system, okay, it means our solar system. It means our solar system. There's only the sun. We don't have anything else. So Pluto is a dwarf planet. It used to be called a planet until 2006. And then we classified it as a dwarf planet, okay? Comets are bodies which orbit the sun in the solar system. Which is the shape of the orbit and how is the sun positioned within the orbit? Again, same structure as the previous questions, okay? 4 options. So the shape of the orbit of a comet, we should know it's not circular, it's elliptical. So C and D are the only options. So now you can easily increase your chances to 50-50 from 25%. And since it's an elliptical, we remember that in an ellipse, okay, the sun is not at the center of the orbit, but it is in one of the 2 foci points of the ellipse. So it's definitely not at the center of the orbit. So D is the right answer. 39, which nuclear reaction produces the release of energy to power a star? Again, theory. Inside the star, we have nuclear fusion of hydrogen through several stages and leading up to helium, okay? So D, that also takes us 10 seconds. 40, something that we also struggled with because maybe we didn't pay enough attention to the theory of Unit 6, space physics. What is the definition of the Hubble constant? The definition, not how we use it. The definition. It's the ratio of the speed at which a galaxy is receding from the Earth. Receding, meaning moving away, okay, from the Earth, to its distance from the Earth. And just a quick reminder, that's what Hubble had. So he had those velocities over here, okay, and he had distances over here, and the graph looked something like this. So the Hubble constant, which was the gradient of this one, was the velocities over distance, okay? So that's very important, and that's a formula that you also needed for paper 4 later on. But that's the theory. So how do we define the Hubble constant? That's how we defined it, okay? So that's all I have to say for paper 2, okay? I hope my comments will be helpful.